So thank you all for joining in our session today. We will start with an overview of Danone Global Data Platform, and then we will take a deep dive on how we leverage data sharing and Databricks to simplify data sharing and governance both locally and globally. I'm Johan Baselto, lead data engineer for Danone Global Data Platform, with over 8 years of experience as a data engineer, and my co-speaker, Gergo.
Welcome, everybody. My name is Gergo Pastor. I'm a resident solution architect at Databricks. I'm part of the professional services team, which goal is to help customers like Danone to plan and implement their next generational data platform. But now, let's talk about why Danone shares data.
So Danone is a leading global food and beverage retailer. And at Danone, our mission is to bring health through food to as many people as possible, guided by our vision, one planet, one health. And to achieve this mission, we produce healthy products adapted to local markets, utilizing sustainable distribution processes. Those products fall into 3 health-focused business lines with our essential dairy and plant-based, so with fresh dairy products and plant-based products, and also our high-protein option, like our iPro brand, perfect for refueling after a good workout, and specialized nutrition for little ones and medical nutrition, and also waters with our well-known brands like Evian. So with products available in over 120 countries, with more than 89,000 employees in 55 countries around the globe, Danone global presence necessitates distributed IT hubs. And that's why a scalable and adaptable data platform is critical to ensure that we meet diverse regional needs and regulation and seamlessly share data, driving improvements for our production and distribution processes. So, like us and everyone in this room, our data platform must constantly evolve to meet the data demand. So, in our previous architecture, we relied on Informatica for ingestion, Informatica ADF Databricks for ETL, alongside Snowflake for BI and as user interface. And as you can see, we utilize a diverse set of tools to fulfill our data requests. And this complexity led us to 3 major challenges. Firstly, multiple solutions driven by individual business needs created a fragmented landscape and reduced our operational effectiveness. Secondly, the absence of centralized governance and standardization led to data silos and data replication. Thirdly, this overall inefficiency drove up platform maintenance and processing costs. So this approach was complex and hindered our ability to scale and innovate. That's why we sought for a solution to consolidate our system and establish a unified data strategy. So for our upgrades in OneSource 2.0, we sought for a solution to consolidate our system into a unified platform, a unified governance for easy access, discoverability, and reusability of our governed assets, and standardization of our processes for scalability and accelerate time to value through self-service. So we transitioned from a siloed, fragmented landscape to a centralized, unified strategy centered around automation and reusable components. So for our new architecture, we center around Azure Databricks for all types of processes, from ingestion, ETL, BI, and data science, with at its core Unity Catalog as our data governance solution. So we have our lakehouse, one house, based on the typical medallion architecture. and accompanied by the user workspaces that we call DTUs, data transformation units, that are personalizable and will be able to offer different sets of capabilities to our users with those. It empowers the business to leverage the power of Databricks across all types of pipelines. So we standardize and replicate our infrastructure in our region of presence with our central lakehouse and the different workspaces for our users. Now, let's take a deep dive on how we share our data with Gergo and learn how our environments communicate with each other.
So let's take a deep dive how Danone shares data in their platform. Danone uses a centralized publishing model. In this hub and spoke model, each region has its own hub and shares its data with the others, with data sharing. These regional hubs are all managed centrally by the central team, and they have different spokes. These spokes are different business units that separate it from each other. Each business unit can only share data with their own regional hub. Then, this platform architecture enables Danone to create additional platform features across the whole data platform. For example, they can ingest common data in the organization, run some ETL processes on it, and provide it to the business units. They can also create standardized features like data quality control and monitoring. The advantages of this architecture also is that the control of the data sharing is centralized, and they can't share anything without the knowledge of the central team. We use a data product model here, where the different business units publish the data product with the data contract. To enable effective data governance, Danone created a data steward role. This data steward role is the owner of the data product itself, and they set the permissions so who can access or can't access the data products. So when a business unit wants to publish something, want to publish a data product, they need to go to the data steward first to certify their data product, and then when the certification is done, they can publish the data product to a common schema. Then other business units can read the metadata, all of the published data products, and then these data products they can request access to from the data stewards. The key point here is to have this data contract. Data contracts is a crucial part that enables us to implement this very complex architecture. Data contracts is basically a written agreement between different stakeholders. These stakeholders are both business and IT stakeholders. This written contract defines both business and technical properties. Business properties like service level agreements, or for example, classification of the data, and technical properties like the storage location. Some of these properties are purely business-oriented. For example, how a business is mapping this data product to a business KPI or goal, that's purely business-oriented, and it's not enforced by the data platform itself. Some other technical aspects can be enforced by the data product itself, for example, ownership or permissions. To be able to write this data contract in a way that is consumable both by humans and by machines, we usually use something that can be consumed by both, so it's usually in a format of JSON or YAML. And one good example for this data contract is the Open Data Contract Standard that you can find on GitHub if you're interested how this looks like. So now let's look at how in-region data sharing works in the case of Danone. You now see the setup in Unity Catalog. You can see that there is one regional metastore, and then below it, there is 3 different kinds of catalogs. One catalog is the business unit catalogs. Each business unit has their own catalog, and they can manage their own schemas and objects below it. Then, for each region, there is 2 additional catalogs. one for tables and one for every other object types. I will go in details a little bit later why we have this separation. In the case of the regional table catalog, we only store tables, and every other object types like views, ML models, or volumes are going to the other catalog. You can also see that in case of views, each reference to a view can come from either the regional part or from the business unit managed part. But they can't cross this border. So a business unit view can't reference something that is coming from the regional catalog, and most importantly, the regional catalog can't reference something that is coming from the business unit. This separation is crucial because it enables us that the data product in the regional catalog are actually independent from what the business unit has. So when a business unit wants to publish a data product to the regional catalog, this is how they are doing it. There is based on the object type, there is different methods and responsibilities. For example, in case of tables and volumes, they can just copy the data from the business unit catalog to the regional catalog. However, in the case of ML models and views, there is a different method. In case of views, they will put the whole view definition into the data contract, and then a central team CI/CD job picks this up and automatically creating the same view definition in the regional catalog. But in this case, on top of the regional data and not on the business catalog data. In case of an ML models, they define the ML model version in the data contract, and then again, a CI/CD jobs that is managed by the central team pick this up and copy this version of the ML model to the regional catalog. This is crucial, again, to have separation between the regional data and the business unit data. Then let's look at how this can be done in a cross-regional way. So when we have multiple regions, then of course we have multiple metastores too. Unity catalog requires us to create a different metastore in each region. Then below that, there is also the regional table catalogs and the data product schema. So here, again, as previously, the data products are represented by a schema. Then we share the data, the tables, from one region to another with the Databricks to Databricks data sharing. But we are not just doing that. We're also applying some additional metadata. Databricks to Databricks data sharing supports column and table comments and also primary case, but they are not supporting all of the metadata. For example, it not provides us a way to mitigate, copy over the text on those tables. So we have a different process that is doing this synchronization, text synchronization for us. Then there is a question, if we use data sharing, then data share will give access to the other region to remotely query the data, but then this will incur some egress cost. And the question arises, what kind of egress cost that we're looking after? So we did some experiment about how the query cost changes when we query the data from a different region. On the left side, you see the results on a bigger table with 3 different kinds of queries. The first query in the first column is a remote query. So it's just using a data sharing table to remotely query the table itself. The second query is a local query, and it's running on the data that is copied over from the other regions. So it's basically doing a full copy and then run the query on it. And the third query is very similar to the second query, but it's doing an incremental copy instead of a full copy. If we look at the bottom, where we see the numbers, yeah, maybe that's not seen because of the subtitles, but if you can see that there is almost 7,000 euro on the left side. So a remote query is very expensive. It's almost 10 times more expensive than the incremental and full copies. And also there is a big difference between the full and the incremental copy. The incremental copy is cost around half than the full copy. So we see that based on the different query type, we have very much big price difference. If we look at the right side of the table, we see the same queries, but on a much smaller table. In this case, the remote query is actually much cheaper than a full or incremental copy. And the difference between full and incremental copy is basically non-existent. They have the same price. So we see that based on the data sizes, there is totally different characteristics and prices. And based on this, we see that we need to choose our sharing strategy based on what kind of data that we share and what the producer's requirements are. So when we're doing cross-regional data sharing, then we came up with a new concept. We have two catalogs now. We have the catalog that contains the shared data that is coming from data sharing, and we have an additional catalog where the end users actually have access to. So the end users, here the business unit region B, can only have access to this second catalog and not on the shared catalog itself. And then we're mapping the tables from the shared catalog to the end user catalog in some way or form. And this way of form can be defined by a share specification. This share specification has two inputs. One input is the data contract itself that is defining that what kind of SLAs and requirements that the business has for this data set. And the other input is coming from the central team itself. The central team can monitor how the end user is using this table, and based on the usage, they can decide if they want to create, for example, a local copy to improve query performance or just create a much cheaper setup for themselves. So they can have a cost control transparently. And the end users doesn't see anything from these changes because they always query the original table catalog on the left side. So this enables us to create something where we can change the data sharing strategy transparently to the end user. This is how the full process looks like. Now put it together. So we have data sharing in the middle. We have two catalogs on the right. But there is more complexity. This works with tables, because table has a concept of a view. A view is basically kind of a link that can create a link to the shared table if you want, without actually copying data. But it doesn't have a similar concept in case of a volume or an ML model or something, other object types. So in those cases, we actually create a separate regional shared catalog. That's what I mentioned before, that I will tell you why we created two catalogs there. And that's why we separate between the object types, because those can be have the similar setup that you see here. So those, we just give access to the end user directly on the shared tables and on shared volumes, for example. And if they need to create a local copy, then they can do it themselves. But because when they change from a local copy to a shared volume, they need to change also their code. So that's not transparent for them. Now let's zoom in these data sharing strategies. There is 4 different kinds of strategies. There is copying data that can be full copy or incremental copy, as I already mentioned. In Databricks, this can be implemented with deep clone or materialized view. The second strategy that I already mentioned is the remote access strategy. This is usually done by data sharing on Databricks, and you can also use data uniform to support more than one data format. Then there is remote processing. Remote processing is a little bit special case because here usually there is actually 2 compute involved. There is 1 compute involved from the third-party side and 1 on Databricks. This can be implemented by JDBC ODBC connection, by Lakehouse Federation, or using a third-party connection. Then the 4th category is data synchronization. Under data synchronization, I mean change data capture usually. It can be one-way or two-way. There is not much difference between one-way and two-way, basically just the number of pipelines that you're setting up. In Databricks, you can implement this with DLT CDC or with Lakeflow Connect, or if you want your own implementation, you can use that as a change data feed for this. So how these sharing strategies, when to choose which sharing strategy? If you have a full copy, then the latency will be hours latency on the data freshness, so how fresh is the data that you're actually querying. And there will be, the query latency will be minimal because you will query local data. But the processing cost and the egress cost will be moderate, as every time you will basically copy over the whole data set. Oh, sorry. Oh?
Why? No,
you're not going to the direction. Can you go back? Yeah. So in case of a remote access, then the data freshness is, of course, as we are querying the remote data itself, it will be always up to date. But then the egress cost will be high. On case of remote processing, the characteristics will be very different from the others, because here there will be two processing, so the processing cost will be double. However, the egress cost will depend on the result set of the query and not on the size of the data set itself. Then there is synchronization. Synchronization will give you the best possibilities across all of these properties, except one, the processing cost. Because synchronization is something that you're constantly running. That means that you need to have a constantly running compute. So now we talked about in-region and cross-region data sharing and also data sharing strategies. Let's talk about what happens when we want to share just partial data. So let's talk about fine-grained access control. In fine-grained access control, how everybody starts to implement this is just to creating views or material as used. When you create a use or material as used, based on how you want to filter, you create a new view for every kind of filtering scenarios. Oh, this business user group wants this filtering by this country, that user group wants another filtering. So you create multiple views. But then when you data share this across region, then you duplicate all of these views. You can easily see that there will be easily hundreds or thousands of these views laying around, what is kind of unmanageable. So we need a different solution. The different solution in Databricks can be twofold. You can either use a dynamic queue. The dynamic queue is basically a special view that is able to define all of these filtering rules in one view. So it's just creating one more object, not multiple ones. Or you can use row-level security. What it means is row-level filtering and column masking that is applied directly on the table itself. So there it doesn't creating new objects at all. And it's using a separate SQL function for filtering, so you can reuse this filter on other tables. But then what happens when you want to share this in another region? Then row-level security is not supported. You can't use row-level security. You need to use dynamic queues. But then when you share data with another region in dynamic queues, you need to use the current recipient function, SQL function, to define what kind of user groups that you want to allow and how to filter. But these current recipients are basically recipients of the data share that's basically mapped to each region. So you can only filtering on different regions. However, in the case of Danone, we doesn't want to filter just on regions, but much smaller groups. That means user groups. So that was not really a good fit for us, because here, even if we create the dynamic queues and share those, we can only filter on groups, on regions. Then we came up with this solution that will just use a shared table and then apply the same dynamic queue definition in each region. So basically, we'll have one common dynamic queue definition, and then in each region, we'll create the same dynamic queue on top of a shared table. In Databricks, we are working on a solution to enable attributes-based access control. And these attributes-based access control rules will enable us to apply row-level security in shared tables, both on the recipient and the provider end. So in some months from now or some time from now, we will have a possibility to not actually use dynamic queues, but actually apply the RLS rules on the tables in each region itself.
OK. Now let's redirect our attention from technical aspects to people and processes, which are equally or even more important. When will my data be updated? When will it be available in my region? Is it legally compliant within my region? All those questions, as platform owners, we need clear answers to those questions. Furthermore, we need assurance that the data commitments will be upheld. And And addressing this concern requires solving organizational challenges, connecting departments and entities, and establishing clear processes between business and IT. So firstly, we need to establish, like Gergo said, a robust data contracts. And those data contracts will address key data governance aspects. First, data cataloging that will map our business catalog, our data to our business catalog. In our case, our domain-driven structure. Secondly, data ownership to establish clear responsibilities for business and technical owners. Thirdly, the data classification to set the sensitivity level of our data assets and fulfill legal requirements like GDPR in Europe and automate our sharing. And lastly, data certification to build trust on our data assets, manage their life cycle, and automate steps like monitoring and quality checks. After, our data platform is also valuable only if the users can easily find and share their data. And prioritizing data discovery is essential for user engagement, platform adoption, and foster collaboration. Increased collaboration will reduce your data duplication and processing costs, leading to significant savings. Data discovery can be governed by 3 different permission models. First, share nothing. It's ultra secure, but expect a lot of duplicates. Then metadata only, like with the browse permission in Databricks, where you can share only the metadata on your datasets. And lastly, the read access by default, where you give access to all of your data with minimal administration, but it's not secure. At Danone, we have adopted the metadata-only permission model, balancing between security with accessibility. And finding data in a data platform is challenging, and everybody searches in different ways. So it's essential to provide a lot of documentation on your data assets, and that needs to be enforced. Documentation cannot be an afterthought. It needs to be forced, otherwise it will never happen. And also, if some documentation descriptions are not available on our datasets, we can leverage the built-in AI capabilities from Databricks to get a first description on our data assets. And also, so finding the data is key. And thanks to the Unity Catalog semantic search, our users can easily find their data. Also, we recommend to our users to add personalized tags to their datasets, like their project nickname or Jira project, for others to easily find their data products in the global platform. Then, as a platform team, our main goal is to provide a good user experience. And this user experience is mainly based on how easy is it to manage their environment and cooperate with others. Sorry. And this is decided by the speed and complexity of our processes, like publishing or consuming a new data product. Speed can be achieved through automation, which is key to quickly unlock our users. And ease of use is achieved through self-service to boost the speed and lower the complexity for our users. So as you can see in this simplified sharing process diagram, our users can define their sharing settings in their data contract. Then, with the stakeholders, through a pull request, we will validate this new data contract in Git, and then in the automation, we'll be able to create the new objects, and automatically create the different replication pipeline if necessary. And automation, thanks to automation, the central team can provide further services like RLS, masking, data quality monitoring, and metadata management.
So now let's talk about what we actually learned from this project. What was the lessons learned? The first one is data sharing is just partially about IT and technology. If you think about it a little bit deeply, data sharing is all about your organization, how your organization works and how the business processes are defined in this organization. So you need to think also about your organization itself. It's not enough to just think about IT and technologies, and it's not enough to just try to enforce all rules with technology itself. You need to also think about your business processes. The second one, learning that we had is this is an interval about what you can choose from. In one part of the interval is the one-to-one sharing, where every data product can be shared by their owner itself. It's kind of a data mesh. And on the other end of this interval is the very centralized setup, where everything is managed by a central team. The one-to-one sharing is creating chaos, while the central team is creating overhead. And you need to choose based on your organization how in this interval, in this interval you are at. Then the third one is a very important one. When you try to think about what kind of data that you actually want to share, you will hear things from business that, oh, we will never share this data. We will only share these two tables, but the others are all secret and we will never share those. This is true at the moment, but later you will see that every data in an organization will be shared sooner or later, especially if you allow it. So be prepared for this and enable them to be able to share the data securely when they need it. And the fourth one is, as I already mentioned it, that your data sharing strategy depends highly on your cost and performance attributions. So you need to have a flexible architecture that is able to support all of their needs. And you will not create a one-fits-all solution. You need to create a flexible architecture that can fit multiple different solutions for the same problem based on the different requirements.
Also, to have complete data products, you cannot only share table or views. You need to handle all type of objects like models and unstructured data, of course. Standardization and robust data contracts foster collaboration and safety in your organization. And for good user experience, a high level of automation and self-service is vital for your platform. I would like to end this session with a quote from our director, Jean-Calvin QM, that with the many lessons learned, a more flexible, unified, and easy-to-maintain architecture in OneSource 2.0, we expect to reduce the data-to-decision time by up to 30%, helping the company react faster to market change. So thank you for listening to our session.